Hi, thanks, Tamara. So I will start with the introductions. First of all, thank you everybody from PyData Global to joining us today. You've probably heard of Polars by now, right? This is definitely not the first Polars talk on this conference or many PyData conferences in recent months. So the point of this talk is not meant to be just another introduction to Polars, right? The point of this talk is to introduce our endeavor. So functime is one of the first Python data science libraries built almost entirely in Polars. And we're going to show how we rewrote one of the most widely downloaded time series libraries, tsfresh, with over 180,000 downloads in a month, into Polars and Rust. And we hope that this talk would matter to you. So we'll match it to you because hopefully we can demonstrate that Polars is in fact production ready, that migrating your existing Pandas and Numpy code base into Polars and Rust is a very reasonable endeavor. If we can do it, I'm sure so can you. And of course, the result of that is faster runtimes, moving away from Pandas into a Rust-based Polars runtime, fewer clock cycles, right? Polars has some really smart optimizations under the hood. And lastly, lower memory usage, in particular from Polars' really smart use of the Arrow columnar format. So just a quick run through our agenda. The first part of this talk would just give an introduction to what is tsfresh, like what does it actually do? And what it does is something called time series feature extraction. We're going to explain why this Pandas NumPy-based library, tsfresh, was so popular, and then explain what were some of its limitations that led us to rewrite it in functime. And after that, I'll pass over the floor to Mathieu. He will give code examples and tips and tricks on how to apply it to your own code base if you do decide to migration in this style.
Okay, so I will give a brief introduction to time series and what is time series feature extraction. So first, what is a time series? So it's a series of data points indexed in a time order. So as an example, you have on the right-hand side the stock price. You can also have sales data or any kind of data that is time-related or time-indexed. So once you have those data, you can, of course, extract features. So the process of extracting features is basically take those raw data and extract characteristics, properties, and attributes on them. So as you can see, the stock price, you can transform in an array of data, and you can extract meaningful features. So here you have an example with simple features such as the mean, max, number of peaks, and so on. So it could be a scalar value, but also a list of values. Okay, so in this talk, we are going to use the panel data long format. So basically, it's when you have multiple time series stacked on top of each others. And this panel data format is extremely nice because you can have all your time series and all the values just in one long format. And usually the first column represents the ID, the second, the time, and the third, the observed values. So in this case, in this example, you have commodities price. So the ID will be the commodity in question. Then the time will be the price at this specific date, and then the observed values, the price in this case. So some other examples to use this panel data format could be sales across product in a retail store. So basically, your product will be the ID of your panel data, and then you have the time, and then let's say the quantity that you are selling, or the quantity in dollars that you are selling this specific day or month. And then you can have also the churn rate across customer segments. So the ID will be the customer segments, and the observed value will be the churn rates at a specific interval of time. And finally, it could be sensor data across machines in a factory. So then the ID will be the machine, so the ID of the machine, and then the observed value could be the temperature, the pressure, measured in a regular interval of time. So now that we have introduced the subject of time series and feature extraction and which data format we are using, I can talk a little bit more about tsfresh. So it's an extremely famous library to do feature extraction because it contains more than 100 time series feature extraction methods. So it's quite large. It's very easy to use. So you can basically in a single line extract many features with pre-specified parameters. So it's nice because out of the box you can directly calculate some features, and also it's flexible because you can provide a list of dictionary that will be the parameters that you use for the calculation of your features. So you have many use cases. The first one could be classification. So let's say you have an unlabeled time series. You have multiple unlabeled time series and some labeled time series, and you want to label the unlabeled one. So what you will usually do, what you can do is that you calculate features on all of them, and then you can associate an unlabeled one with a labeled one, sharing similar characteristics. Then you have also regression tasks. So if you want to predict future, let's say, price of a stock, what you can do is include features from many different other time series that could impact the price of a stock, let's say. So this is a different another use case. And finally, anomaly detection. So if your sensor, so if you observe some strain values with feature extraction, you can easily remove those values for a given criteria. So why functime rewrote tsfresh in polars? So it's a good question, and to answer this question, I will first introduce functime and then introduce polars as well. So functime is a machine learning library for time series prediction. So it allows you to perform global forecasting on panel data format. So basically, you can use multiple time series to predict the future values of one of them. Then you have also pre-processing tasks. So you can do, for example, first differences. If you want to make your time series stationary, or you can use boxcocks to have a look like data that look like the normal distribution. Then you can also perform cross-validation with functime. So you can take your training sets and split in different folds. So it will improve the performance of your model. And finally, you can do time series feature extraction for both expression and polars expression and polar series. So this talk is mainly about this time series feature extraction. So for polars, so Chris mentioned it, but probably you know already, but it's a query engine written in Rust with a dataframe API. So under the hood, it uses Arrow as the memory model. So it's this columnar memory format, which allow you to perform a very efficient operation. Then it's multi-threaded, so it will use all the threads of your CPU on your machine. So it will allow you to perform operation very fast, especially in specific contexts. Also, you have to optimize lazy queries. So instead of executing directly your operation, what you can do is that you specify your operation in a lazy mode, and then you execute them only once you have defined all of them. And it helps somehow the compiler can do a further optimization in such a case. And finally, it handles dataset larger than memory. So now I will hand it to Chris, and he's going to explain you what was the motivation to include this into functime.
Right. So tsfresh is an incredible library, right? Super convenient. In just one line of code, you can generate many different features for your time series. But it's starting to show its age. So it was first released almost 6 years ago. And in particular, it's starting to have limitations both in terms of performance, where you want to scale to not just one time series, but compute like hundreds of time series for n number of time series. So the panel data format. On top of that, it also has what might be considered an outdated API design. So no type hints, a few non-explicit keyword arguments. And we found that Polars, with its fantastic use of multi-threading, with its fantastic use of efficient memory, data structures, in particular a list type, was able to address many of these limitations. And as we continue doing this rewrite, many more interesting tips and tricks that we learned. And that's why for the rest of the talk, Mathieu will provide code examples for how you would use this in functime, and also how you might apply some of the learnings to your own code-based migration.
Okay, thank you, Chris. So now I will show you a quick code example. So let's say you have a data frame in a panel format, and you want to calculate some features. So what you will do is that for each of the time series you want to calculate features. So what you will do is that you will perform a group by operation. So in this case, for the specific ID, so the first column, and then you will aggregate. So this section, as you can see, we calculate Polar's features. So very simple one, so max, mean, and min. And this is what is coming out of the box with Polars. But what you can do is with functime, just with small differences, you will use this register expression namespace, so in this case called TS, and then you can calculate a bit more complex features that has been developed within functime. So you can see the code doesn't become too complex, and it's extremely easy to use and stay consistent with the Polars API. Okay, so now that I show this quick code example, I will explain a little bit the benchmark we did. So we wanted to compare tsfresh leveraging Pandas and versus functime leveraging Polars. So the first one that we did is that we wanted really to compare the performance of a single feature without any context. So what we did is that we took the M4 dataset with 9 million rows, and we were comparing, calculating a single feature on a single vector containing 9 million rows, and comparing the speedup. So as you can see in this table, ranked, of course, by speedup, it's faster. Our implementation is faster. What I would like to mention is that for the 10 last features, we are actually slower, but this is something that we are working on. So I wanted to be transparent for this. So, okay, this is the benchmark for the features on themselves. So now we did also another benchmark. So we took the S&P 500 with 120K rows, and we were calculating the features in a group by context. So we were calculating the features for each of the stock and the observed value that we had. So it was the price in this case. And as you can see, using the power, so the multi-threaded power of Polars, we managed to have a insane speed up. And in this case, all the features were actually faster. Okay, so now I would like to talk a little bit about the learning that the things we learned all together. So with this community of contributors, and we made a top 7 of them about Polars and functime. So the first one is that Polars is a very expressive language. So the method that you will use states explicitly what it does, and it makes it quite easy to understand a code just by a function just by reading the code immediately. So you have this RLE function, for example. So it calculates the length of runs of identical values. And we used it in a feature that calculates the length of the longest consecutive subsequence in X that is bigger than the mean of X. So it's longest streak above mean. So you can see on the left-hand side is the functime implementation, and on the right-hand side is the tsfresh one. And you can see that this RLE method is exactly the equivalent of this getLength sequence where. And I think you can immediately see that when you read this code, it's a bit easier to understand for you. So it's quite an expressive language in this regard. Then the second learning that we have is that Polars namespace are awesome and clean. So as I showed in the code example, you just need to add this little .ts dot the name of the feature. And to do so, you can basically use what is made available by Polars. So use this decorator to register your expression namespace. So in this case, I register the TS expression namespace. Then you define your class. You have a constructor with only one attribute, which is the expression, and then you can define all the features. And this is how we created this all this set of features for Polar's expression. Then the third learning is that the common sub-expression elimination is a very powerful feature of Polar. So if you don't know what it is, it's basically a compiler optimization that is searching for instances of identical expressions. So let's say you have a huge data frame, you want to calculate many features on it, and you know that you will do a lot of repeated computation. So for example, in many different features, you will calculate the mix, the mean, the absolute value, and so on. If you are in the case of a lazy query, Polars will basically calculate it once and then reuse it multiple times. So this is what you can see in this example. So you define your Polars lazy frame, then you apply the context with column, and then by using the explain method, you can see the optimization that has been made by the compiler. Okay, so the fourth learning is that Rust and Polars is a viable alternative for scientific computing to Numpy and Numpy. So this is true in specific use cases. So for example, a code that cannot be completely vectorized. So this function is Benford correlation. So the Benford law states that leading digit is likely to be small in a real data set. And what it calculates is that it will take the distribution of the leading digit of your time series and then calculate the correlation with this Benford law. And to do so, you will perform some string operation, so to extract the leading digit. And this is, of course, a code that cannot be completely vectorized, and it's extremely fast using Polars, as you can see in the benchmark. Then also, it's quite adequate to use Polars for manipulation on a single vector. One of the examples is index mass quantile. So the index mass quantile calculates the relative index of a time series X, where Q% of the mass lies left to this relative index. And as it will calculate some features on this single vector, sorry, Polars is quite fast for this. Then also a learning something that we learned during the development is that tsfresh is very nice library, and our work is largely inspired from it. But we were thinking that you can improve a lot this API, and this is, I think, what we did. So for example, for energy ratio by chunks. So for this feature, you will take your time series, divide it into chunks, and calculate the energy ratio, and then the energy, and then you will calculate it as a ratio, such as the sum will be equal to 1. So in tsfresh, you can see that you need to provide an argument param, which will be a list of dictionary. And we think that this is not the best way to define a feature, especially because then it returns a list of tuple, which is a bit weird to handle, I would say. And what we did with functime is that we just provided simple arguments in such a way, and then we were returning a list of lists where every chunk was just indexed by the list index. Then also to improve a little bit the API for the change quantiles. So basically the change quantiles, you will calculate the distribution of your time series. Then you will select only a corridor within 2 quantiles. And within this corridor, you will compute the changes. So xt minus 1. And in tsfresh case, what they were doing is that they were aggregating as a string argument and then returning a float. So in this case, the mean. And we think that it's just better to let the user do do this calculation himself. So if he wants to use the mean, the median, or whatever, he could do this. And therefore, we were returning a list of lists. So you could just do .list mean if you wanted to calculate the mean in the same way as tsfresh. Then another very nice feature of Polars is the Polars plugin system. So if you want to write your expression as a Rust function, so you can compile this Rust function and register as an expression into the Polars library. And for this, you need mainly 3 ingredients. So Rust install, Mathieu build system, which is the equivalent of setup tool somehow, and then the Polars plugin system. And for this, we have one example that Teachin was implementing, so the Lepenziv complexity. So the Lepenziv complexity is computing the number of different substrings that you can find in a binary sequence, reading from left to right. So it's basically it returns the value that represents if the binary sequence is regular or not. So if it's low, then it's quite regular. And so this implementation has been made by Teachin. So his pseudonym is Abstract QQQ, and this work has been influenced by Lilian Besson. So you can have a look at the code in the repo if you're interested to also implement a Rust function to make it compatible as a Polars expression. And the final learning is that we're implementing an iterative development approach and a strategic division of work. And I think this is what made this work quite successful, because quite fast we were 8 developers at the beginning. We divided the work to implement 10 features each. And then in the meantime, we were writing unit tests and optimize the features to have a very good quality of code and something that will be very reliable in time. So we were very handling those edge cases and optimizing. So I'm quite proud that we managed to write all those unit tests and be able to present something that is quite reliable to the users. So then the final element that I would like to mention is, why would you use functime for the features extraction? So the first argument would be the speed, because as you can see, if you have many time series on a very large data set, you can really leverage the predefined set of features that we have made available, but also all the capabilities from Polars. And I think we have to recognize that this work is quite amazing. But it's not only this argument, but also the fact that the API is very consistent, and it's extremely easy to use. So even if you have a small data set, I think it will make sense, because it will make your code a bit easier to read and also easier to debug. So there is this famous quote that I took on LinkedIn, came for the speed, stayed for the syntax, and I think it applies quite well for Polars, but also for functime, as it has been developed in the same paradigm, in the same idea. So I would like to thank all our contributors, and especially Abstract QQQ, who made a lot of work to optimize all the features and is very active in this regard and the Polars ecosystem. And the next step for the feature extraction part will be to provide a wrapper around 100 of pre-specified features, such as the one in tsfresh. Also do feature selection based on statistical significance. So this is something that was also available in tsfresh. And finally, I would like to mention that we are community driven, and join our Discord if you want to ask questions or give some feedback about the use of functime. Now is the time for Q&A. So thank you for listening, and if you have any question, feel free to ask.
So I think I see one question about tsfresh uses Dask to distribute calculations. Have we been able to use Polars? So I think early on you saw the benchmarks for the group by operation in Polars. We managed to have 200x speedups. So this hopefully answer the question about Dask, right? In tsfresh, because they implement features in Numpy, they have to use something like Dask to distribute that code for each time series. So you're computing hundreds of features for each time series, parallelized using Dask. What's great about polars is with a simple dot group by, or if you want to do rolling features, dot group by underscore dynamic, you get that same parallelization, but on a single instance, right? With extremely fast, greedy work stealing and significantly faster sort of scheduling of work than Dask, because you're no longer sort of communicating between different workers. Is all done on a single instance. Hopefully that answers the question, Giles. For Marco's question about do we accept Pandas data frames? Not at the moment. So we made the explicit decision when we first created functime to make it a polars only library as a way to enforce that discipline as developers of this library, to make sure we use only polars. And we want to maintain this philosophy moving forward, unless there's a strong argument why we will want to accept pandas, because I think it's relatively simple for the developer to do that themselves outside of functime.